y dot u2 divided by u2 dot u2 and y dot u3 divided by u3 dot u3. So basically just the calculation with the formula 1, 2, 3 formula, and then we will get the expression as the linear combination of the orthogonal bases. And next, we're introducing the orthogonal projection. As mentioned in the Tuesday's presentation, orthogonal projection is critical to this section. 就是这是这个章节相当重要的概念。So we are given a non-zero vector u in the Rn space. We will consider the problem of decomposing a vector y in Rn into the sum of two vectors. One vector is a multiple of u, and the other vector is orthogonal to u. That is, we want to write y equals to y hat plus z. All right, we want to decompose y into two parts, y hat and z. And the relationship between them is the following. So y is this one. This is a non-zero vector. And then we want to decompose it as two parts, which is y hat here and z. And since z equals to y subtract y hat, z 等于 y 减掉 y hat. So we find out that we have y equals to y hat plus z. Okay, and these two parts are orthogonal. And y hat is projected on a line. Projected y projected on line with the direction u, and z is perpendicular to u. 我们把 y 分成了两个部分的相加，其中 y hat 是在 u 这个方向的线上，然后 z 呢则是与 u 垂直的线上。那任何一个非零的 y 都可以被分解成这两个部分。Okay, so since y hat is on the line of u, then y hat can be expressed as a multiple of u. 那这边呢是一个推导的过程，说既然 y hat 是最后是被投影在 u 这个方向的线上，那么它的数学表达是一定是某一个 scalar alpha 乘以 u. Since y hat is on the line with the direction of u, it can be expressed as a multiple of u. So we can express y hat as a scalar alpha times the vector u for some scalar alpha. And because y subtract y hat is orthogonal to u, then that means we can express y minus y hat equals to y minus alpha u. And this should have a inner product with u being 0. So we have y minus y hat equals to alpha times u, inner product with u, and the inner product is 0. And then find out the expansion of the expression, 把这个数学式展开。And it can give us a relationship between alpha and other expression, or we can find a expression for alpha. 那根据前面这个 y 减 y hat 与 u 垂直，所以它们的 inner product 为0的这个关系，我们可以推导出 alpha 这个 scalar 它应该要满足 y 跟 u 的 inner product 除以，它应该要满足就是对，它会等于 y 跟 u 的 inner product 除以 u 跟 u 自己的 inner product。所以这个是我们透过上面这个式子推导而来。那至于 y hat 就会是y hat 它会等于 alpha 乘以 u， 所以我们就在旁边再乘以一个 u。y hat is equivalent to alpha times u. So given the derived result alpha equals to y dot u divided by u dot u, we can compute y hat in this formula. And here are some English names for vector y hat. Y hat is called orthogonal projection of y onto u. And vector z is called components of y orthogonal to u. So this is a another way to say the same thing. We find out that y hat, we have derived y hat equals to this result, the same result as we derived. Another notation of that is called projection onto a subspace L. Such a subspace L is spanned by U. So here the subspace L is the line passing through U and 0. So U is the basis in that subspace. So sometimes y hat is denoted by projecting L, orthogonal projection of y onto L. And the formula is the same as the radiation using that alpha scalar. 那这边呢是在说，我们如果是前面的那个 orthogonal projection， 我们已经推导出 y hat 在 u 方向这个直线上的投影，垂直投影是这个公式 y hat 等于 y 跟 u 的 inner product 除以 u 跟 u 的 inner product， 然后再右乘一个向量 u。那此时呢，我们要考虑的是说有一个子空间 L， 它的 basis 是 u 的话，那么这个时候呢，它的公式会跟前面的那个东西一样，而且我们可以把这件事情又另外记载成 PROJ， 然后有一个下标 L， 然后旁边再写一个 y。那这个就是说 orthogonal projection of y onto subspace L, where the basis of the L subspace is U vector. So that's an important formula we have to memorize. 前面那个是我们需要记忆的公式，就你需要熟悉的公式。当然说它的推导本身并不困难。So in this example, we are given a y vector, 7, 6, and then a u vector 4, 2. Find the orthogonal projection of y onto u. Orthogonal projection of y onto u. And then write y as the sum of two orthogonal vectors. That is, we want to write y equals to y hat plus z. And the two vectors, one in span of u. So this one is in span of u. The other one, z, is orthogonal to U. So we required to use this formula. So this is the formula you should use. Y hat equals to inner product of Y and U divided by U and U inner product. So this gives us 40 divided by 20 and then times the vector U. So we can calculate Y hat equals to A4 vector. And next, Y subtract Y hat, you get -1 and 2. So as a result, Y is 76 equals to A4 Y hat plus Z -1 and 2. And this is a decomposition that the example asks for. And we can also check if Y hat and Z are perpendicular. So we take the inner product at A4 and then -1, 2, and find out that the inner product is 0. So they are indeed orthogonal. Okay, so we will end right here and then continue next Tuesday. Do you have any questions?